or don't understand or kind of hit a problem, I will cover it here. So I'll answer any questions that you might have. Okay. And did I answer your questions from last night? Okay. And one other thing you can do is if you take a picture of the problem and email me, and I'll get you kind of signed in and so you can email me. I'll get back with you pretty quickly. Yes. You can put it on my desk. And I'll respond pretty quickly to those. So it doesn't bother me when you email me. You can email me at 2 a.m. if you want. I won't respond because I'll be asleep. I'm normally asleep by 11. If I'm up at 11, it's a miracle I'm up that late. But so I'll answer it pretty quickly. If I don't see it before I go to bed, I'll answer it the next day. Yeah, well, actually, I'll probably respond to it before then, but yeah. Now, what we're looking at today is synthetic division. Synthetic division. And synthetic division, for the most part, there's been a few who like long division better, but synthetic division is another way to divide polynomials. Now, I went about for first hour going to go and write all the steps out. This is how we do it step by step, but I feel like it's going to be a little bit easier if we just work through it than it is to try to put all the steps up there and see them. Now, whenever we do synthetic division, the first thing we're going to do is to solve what we're dividing by, the m minus 3, for the value of m. We want to get m by itself. So we set it equal to 0. So to get it by itself, we would add 3. So this is the first main step. Which tells us m is equal to 3. Bless you. So the first thing we'll do is we put the number in the cubbyhole. So we'll do a cubbyhole in line to get it set up. And we put the number that we got for getting the variable by itself in the cubbyhole. Good with this so far? For the most part anyways, right? Now the next part is we're going to take all the coefficients, the number in front of the variables. We're not going to take the variables, we're just taking the numbers in front of them. And we have to have each variable. So here, the biggest one we have is m to the third. So we'll need a value for m squared, m, and our constant. We'll need each one. And if there's one missing, we put it in a 0. So the number in front of m cubed is 1. Then we put the next number, which is negative 13, followed by and 18. Okay, now we're going to officially start synthetic division. And the first step in starting synthetic division is we drop the first number down. So we drop the first number straight down. Okay, now I'm going to be drawing arrows. You can draw them if you want. I wouldn't advise it because we're about to have a whole bunch of arrows because I'm going to show what we're doing. Because the first main thing we're going to do is take 3 and multiply it by 1. And 3 times 1 is 3. So we multiply the number in the cubbyhole by the number under the line. So 3 times 1 is 3. And we place it under the next number. Add straight down. So we'd have negative 13 plus 3. questions on this so far? We multiply again. 3 times negative 10. And we place it under the next number. And then we add straight down. So 24 plus negative 30 is negative 6. Do it again. 3 times negative 6. And lastly, negative 18 plus negative, 18 plus negative 18 cancels out and is 0. Do we have any other numbers left after that? So we stop. What I always do is I box the last number under the line. The reason I box it is a reminder to myself, this is the remainder. This is the remainder. And so for us here, the remainder is, we don't have one. Okay. Now, I'm going to use a different color because we don't have to write this one in. Because what we're going to do next is, well, we need variables. Because we took them out for synthetic division, we've got to put them back in. And the first one here is going to be m to the 0. Well, what is m to the 0? 1. It's just 1. We're multiplying it by 1. So we don't need it, but I put it in there just as kind of so we can see it. So this here, 6, is going to be with m to the 0. We're increasing the power by 1. So really, it's not there. It's just a constant number, which means the one with m is going to be m to the first. Because we start at 0, then we would have m to the first, m second. So essentially, the one next to it's m to the 0, or we just don't have one. Then it's m to the first, m to the second, and we keep going, increasing it by 1. So our final answer is m squared minus 10m minus 6. Yes. Questions on this here? Are you ready for the next one? So, yeah. In years past, I've had to get them bigger so that they'd be easier to see. Oh. Yeah. It's not going to be easy to do it with. There we go. Because the old projectors used to not view well, so I needed to blow them up to make them visible. But now this screen is so much nicer, it's pixelated them out. So one of the things I've told them, I don't know, your old school graded stuff or your math teacher graded stuff, it's neither here nor there. I'm just going to let you know, because especially it starts out with V. If you end up putting your answer in terms of X, I don't care. It's just a variable. And I will do that a lot. I will end up switching it back to X because we're so used to doing everything in X, not V. And a lot of these here, I will end up writing the answer in terms of X. It's the same thing. We're not. It doesn't really make a big difference. So I was just letting you know. Here, we'll go on and get this one started. So the first thing we need to do is to get V by itself. So we would cubby hole and aligned. What goes in the cubby hole is -4. So we can go on and start putting the numbers across the top. So we would have 8. Because we started out with v to the 5th, so we have that one. Then we need v to the 4th. We don't have a v to the 3rd power, so we put it in as 0. We also don't have a v to the 2nd power, so we put it in as 0. We do have v to the 1st, or v, which would be our 5, and then 20. Now this one here is actually not that bad, even though we do have a lot of numbers. So we'll start off by first dropping the 8. And we'll do -4 times 8, which is -32. -32 plus 32 is 0. Now everybody's favorite multiplication problem, -4 times 0 is 0. I'm not going to specifically write that one out. I feel like we know that one pretty well. Now the next one, 0 plus 0 is, then we do -4 times 0. 0 plus 0. -4 times 0. 5 plus 0 is, our next one is, -4 times 5 is, so we'll put that in there. And -20 plus 20 is 0. Now when we put our variables back, our box 0 is the remainder. The 5 is our constant term, the one without a variable. Then the next one's going to be v. The one after that is v squared, then v cubed, and then v to the 4th. So if we wrote this out, our first one would be 8v to the 4th plus because I don't need to include 0v to the 3rd or 0v squared or 0v. They're all just 0. These are all gone, so we're just left with 8v to the 5th plus 5. That's it. Questions on any of this here? We ready for the next one? Oh, no, I don't want to add anything. Okay, this again is way pixelated. There we go. A little bit better, yes? Okay. So this first part of it, I want y'all to watch. I don't want you to write this down. So with this here, if we were doing this with long division, 3 or 4x, yeah. Let's try this one more time. Nice. So we have 3x cubed minus 4x squared, da 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 da. Out front we have 3x minus 1, yes? So with long division, the first thing we would see is what times 3x gives me 3x cubed. Almost. Just x squared, yes? And the number in front of it would be 1, yes? So if we did synthetic division, so we'd start off 1 is equal to 0, yes? Yeah, we'd add our 1. So again, I would say watching at this point. So we would add 1, 3x is equal to 1. Divide by 3, so x is equal to 1/3. Then across the top, we would have 3, -4. And we'd keep going on. And our first step would be to bring down the 3, yes? So that means the first term, the biggest number that we would have for this is a, but with long division, what did we say it was going to be? 1, yes? There's a discrepancy there, isn't there? And there's a reason for this, and there's a reason I did this, is to pull this out, is really that anytime there is a number in front of the variable with the biggest exponent, we have to divide the entire thing by that number. So here, we're going to have to divide every single term by 3. To be able to get the correct solution here. Now, the first one's nice. Because 3x cubed divided by 3 is x cubed. Minus, does 4 divide by 3 evenly? Negative 4/3. Minus 17/3 x plus 6 divided by 3 is we have to divide it all by 3 for this to work. So synthetic division is very nice, especially if we have x minus or x plus a number. It works very well. If we have a number in front of x, we have to divide the whole thing by it. Now, we can go on and start doing the next part. So it's going to be here, x minus 1/3 is equal to 0. So we would add 1/3. So that part stayed the same. Inside the little cubby hole is 1/3. Across the top is going to be 1. Negative 4/3. Negative 17/3. 2. And here we drop the 1. Now for most of this here, you can use a calculator. You can use a calculator for this whole thing. Because again, our first step is to multiply 1/3, and so we do 1/3 times 1, which is now we are going to add straight down, yes? Well, a calculator will do that quite nicely, won't it? So we do negative 4/3 plus 1/3. And if we did this by hand, the denominators are already the same. So we can add the numerators, yes. Negative 3/3, which is negative 1. Then we multiply by 1/3 again. We'd have 1/3 times negative 1, which is negative 1/3. Then we would add negative 17/3 plus negative 1/3. Yes, because it'd be negative 18/3, which does reduce to negative 6. And last but not least, 1/3 times negative 6 is, and 2 plus negative 2 is, and again, at this point, we can put our variables back in. So this is going to be the remainder. The number right in front of it is our term without a variable. Then we'd have our term with x to the first and our term with x squared. So we have x squared minus x minus 6. Any questions on any of this here? We good with this here so far? We'll look at one more of these. and then we'll move on to the next thing because I feel like y'all feel pretty comfortable with this. Yes? For the most part anyways. Yeah. And most likely doing a few on your own is going to help you better understand it. It's always easier when you have someone who knows what they're doing walking you through it. And I've been told a few times I make this look easy, so. Now, when we do this here, we do need to get x by itself first. So x plus 1 is equal to 0. Minus 1 from both sides, so x is equal to -1. Which means we put -1 up in the cubbyhole. Now across the top, we'll have 3, -2, 2, -5, and we'll bring down the 3. For this one here, I'm not going to write out the multiplication because I feel at this point we get an understanding of what's going on in those steps, yes? So the first thing we're going to do is -1 times 3, which is -3. We add straight down. -2 plus -3 is -5. We do -1 times -5, which is +5. Add straight down. 5 plus 2 is -1 times 7 is -7. Add straight down, we get -12. -12 is our last number, so we box it, so that is our remainder. So this is the first one here that we've actually had a remainder with, yes? Other than 0. Because if the remainder is 0, we don't have to add it back in because it's not adding anything to the equation, 0. But here's our remainder. Now we can put the variables back in just like what we've done before. Since 7 is the first number before the remainder, it's just going to stay 7. The number before that has x, and the number before that has x squared. So we have is 3x squared minus 5x plus 7 plus. Now, since we do have a remainder other than 0, we do have to add it back in. So we put what the remainder's value on top, so -12. Now, what were we dividing the polynomial by originally? X plus 1, yes? It's what goes in the denominator. Same as yesterday. So we get this here. Now we can write it a little bit differently because I can pull that negative out of the top of this here. I can pull that -12, the negative out front, and change it to -12 over x plus 1. That's the exact same thing. I will take either version of the answer. Questions on any of this here? You feel good with this? I mean, for the most part anyways. Okay. If we feel comfortable, I'm going to go on and skip ahead. So I don't always do every single example problem in the note sheets. I put them all there just in case, because if y'all need to see more examples of the type of problem, they're there. I will go over them. But if y'all feel comfortable with it, there's no reason for me to keep going over it. We'll move on to the next time. And this is easier than you think. Now this here, we want to use synthetic division to evaluate for when x is -4. So we did this on Tuesday. We've evaluated before. If we evaluate for this here, what we can do, we can plug it into the calculator. So, well, there it's plugged in. I keep forgetting to clear that. So we would do 5 parentheses, -4, not squared, cubed, minus -4 squared, plus 13 times -4, plus 29. And we would get -359. We've done that before. Either calculator, the graphing calculator or the 30xs. So you can do that. We just replace the variable with that number. So we get this here. Okay. What I want to do for this problem is the synthetic division. Now, they were nice enough to give us the value of x. X is equal to -4, which means the number in the cubbyhole is -4. We don't have to do anything to it. We just plug it in there. Our numbers across the top is 5 for x to the third, -1 for x squared, 13 for x, and 29. So we bring down the 5. So we'll do -4 times 5 is -20. We add straight down. -1 plus -20 is -21. -4 times 21. Negative is going to make a positive. 4 times 1 is 4. 4 times 2 is 8. 84. Then we add straight down. 13 plus 84 is 97. Then we do 97 times -4. Well, it's going to be negative 388. And last but not least, we can add straight down. So 29 plus -388 is -359, yeah. Why does that number seem familiar? So when we evaluated it in the calculator, we found that the value is -359. It works out that the remainder is the same thing we can evaluate it with. So we can use synthetic division to find out what the value would be also. Yes.
It's something with 3, like the value of 3.
We'll get there. Any other questions on this here? We're going to look at one more of these. Yeah. I just wanted to find us to evaluate it.
So,
-359.
So that's the answer that they wanted.
Yeah, so when we evaluate it, the remainder is the same as if plugging in that value.
So we didn't need the 5, -3.
Because the rest of it would be the other part of the function, but the value that it would have if we plug that number in would be -359. So we'll do the same thing here. So we'll set it up. We'll have 5 in the cubbyhole. Across the top would be 4, -10, -21. We bring down the 4. Then we'll do 5 times 4, which is 20. -10 plus 20 is 5 times 10 is -21 plus 50, 29. So the value of this function when x is 5 is 29. And that's it. And almost, especially if you get really good at synthetic division, you can almost use synthetic division to evaluate it faster than you could probably plug it into the calculator, most likely. Any other questions on any of this here? Because that's it. That's all we were mainly covering today. There is one problem that we will do. We'll get there. Now, any questions on this so far? We like this for the most part. I mean, we could be doing worse things. Yeah. Now, this one here, I'm going to show you guys how to do this. Now, when I was in high school, we would do these here. If a problem like this came up, or what we're dividing by, the divisor was a quadratic, was bigger than a linear function, had a degree 2 or higher. We would do this by long division. That would be the way to do these here. Thank you. Finished?
Yep, thank you.
You're welcome. We would do these by long division because they're easier to work that way. And that's the only way we ever did. Because when I was in high school, that's the only way we ever covered it. In most high schools, that's what they'll do. Most college classes, they will do it by long division and that's it. I never saw it with synthetic division. And it wasn't until a year or two teaching here that I had a student ask, can we do these with synthetic division? My initial answer was no, we can't do it that way. But I said that because I'd never seen it done that way. I've never talked about it, I've never seen it. It's just never been introduced. So I ended up saying, okay, I will look. And it is possible to do these with synthetic division. It's just not normally taught. Okay? Now the process that we do this with isn't too different, but we do have to add a few more steps. Because instead of having 2 terms, we have 3. Now, with any of these here, we're just wanting to get the variable with the biggest exponent here by itself. Because on all the ones we've done so far, the variable with the biggest exponent was just x. So now we're wanting to get x squared by itself. That also means, just like where we had the one with 3x as the biggest one, if there's a number in front of x squared, we've got to divide that number out by everything. But here, luckily, we don't have that. So we can start off with getting x squared by itself. So the first thing we can do is add 4. Which will give us x squared minus x equals 4. Okay. Now, if you notice for this one here, I made the little cubby hole a little bit bigger. Because on the previous one, we would have just had the 4. Now we have the x and the 4, yes? And again, we're not pulling any variables in, we're pulling the numbers. So we will have the 4, but what's the number in front of x? 1. So we'll have 1 and 4. It's not 14, but we have 1 space 4. So if you want to put a comma between it just to make sure, or put a little dotted line, either way works. So we can put a comma or a dotted line to make sure we know those are separate. Now again, like we did in the previous ones, we'll take all of the coefficients, the numbers in front of the variables, and putting zeros in if there's any missing. So across the top, we would have 2 for x to the 5th, 1 for x to the 4th, negative 15, negative 2, negative 24. Now, in all the previous ones, we only had 1 number in the cubbyhole. Now we have, in all the previous problems, we had 1 line. Now we're going to have 2. So for each number that we have, so if we had a cubic, we had 4 terms for the divisor, we would have 3 numbers in the cubbyhole, and we would have 3 lines. Now again, the first main step was what? Drop the first number. We're still going to do that, but this time instead of dropping it below the first line, it's going all the way down. Going all the way down to the bottom. Now we come over to the next one and drop that number down past the first line. So drop the first number all the way down, next one drops 1. So if we had a third term, third line, first number would go all the way down, second number would go down 2, third number would go down 1. So it kind of does this stair step. We good with this so far? Now the multiplication is still going to be with this bottom number. So we're going to do 1 times 2. And 1 times 2 is? And we put it under the next number. Now the 4 does not multiply with this here. We're still going completely with this one. So we would do 4 times this 2 down here. And 4 times 2 is 8. And we put it above the first line. Yes. And now we add straight down. So we do here 1 plus 2 is 3. Up above, negative 15 plus 8 is negative 7. Questions on this here? Well, we do it again. We're going to do 1 times 3 now is 3. 4 times 3 is 12. Add straight down. So we have negative 7 plus 3 is negative 4. Up here, negative 2 plus 12 is 10. We do it again. Now we do 1 times negative 4 is negative 4. 4 times negative 4 is negative 16. We add again. 10 plus negative 4 is 6. 10 plus negative 16 is negative 6. Well, we multiply again. We're going to do 1 times 6 is 4 times 6 is, and again we add. Negative 6 plus 6 is negative 24 plus 24 is. Now, when we only had 2 terms in our divisor, what we're dividing by, how many remainders did we have? 1, yes? So now we have 3 terms. So how many should we have in our remainder? 2, yes? And the way I normally do this is I'll go on and circle those last 2. Those last 2 are going to be our remainder. Now here it's 0 and 0, so it doesn't make a real big difference. But kind of as we've been doing outside the remainder, the farthest number to the right was our constant. The next one was the variable to the first power, squared, cubed, increasing, yes? Same thing's true with the remainder. This here is going to be 0 with no variable. This one here is going to be 0 times x to the first. So if we had 4 terms that we were dividing by, the next remainder number would be x squared. Because the remainder is always going to be 1 degree less than what we're dividing by. Now that still holds true with this here. 6 would be just our constant term. Negative 4 would have x. 3 would have x squared, and 2 would have x to the third. So we have 2x cubed plus 3x squared minus 4x plus that'd be our final answer. Yeah. It could be a coincidence or it could be a pattern. We'd have to see more to determine that. Yeah, so they would change if it was, if it had been x squared minus 2x, so we would have gotten different values. But any questions on this here? This here isn't bad. I mean, it's a little bit better than long division with these, but there is a lot more to keep track of than with just 2 terms, all the other synthetic divisions we've done. I show you this here because, one, I want you to at least see that it is possible and see how to do it. Now with these here, if you want to go back to just doing these with long divisions when we had those 3 terms, that's fine. If you want to do these with synthetic division, that's fine too. But that's it with this here. So on page 187, your homework is problems 12 through 18, 23, and 25 through 28. Okay. Slightly